first thing, our next event will be on February 26th here again, and it's going to be given by Jason Bondersmith, data extraordinaire, on Capital One. It's going to be on data security and secret management via APIs. Smart stuff. We also have a LinkedIn page now, so find us, RVADE. So it's kind of how we stylize Richmond data engineering.
Okay, I get to talk about myself. So I will also be giving a presentation in February to our sister brother organization, the data science community. It'll be talk on sort of from a personal perspective, my journey into data science coming from a completely different field. And also a reminder, the RVA Tech Data Summit is coming up. We'll be attending. I know this is a really good event. I went to it last year. So it's actually a 2-day event this year. One day full of workshops, and the other day with speakers from all over the Richmond area. Topics include everything from high-level management stuff to really getting deep down into the weeds into some of the data science and data engineering and the like topics. So we can only recommend it.
It's capitalized because that's how it is on the website. So we're not like, we don't pay to do it or anything. Yeah. We capitalize our name because, it's us. All right.
Yeah.
I think that's all our announcements.
Yeah, exactly.
Take it away. By show of hands, how many people actively use Airflow? Okay. How many people has heard of Airflow? Okay. I thought that was what we were going to happen. So I'm going to talk about what Airflow is, a little bit about Kubernetes and Docker, and then how do they kind of work together. So a little bit about myself. I'm currently a data engineer at CarMax. I graduated from VCU, College of Engineering. I'm one of the co-organizers for the Meetup group, and my interests are ML productionization, natural language processing, and Python. So what is an orchestration engine, and why do I need it? So imagine that you had 3 Python programs, right? First.py, second.py, third.py. And they're not doing anything but just printing first, second, third. And you wanted to orchestrate them in such a way that first would run first, second would run second, and third would run third. There's a couple different ways you could do this. What we could do is we could write a Python wrapper program around all of those and execute those in order. X has some difficulties with security and things like that, but it's good enough for what we're doing here. Now what if we have the similar flow, first.py, and it produced some property. And if it was true, we wanted to run the program second, and if it was false, we wanted to run the program false. Now again, if we try to write the same Python wrapper program around this, you see it gets a lot more difficult. Now imagine you had 100 or 200 things you were trying to orchestrate with all different patterns and variables being passed around and things like that. This gets a little unwieldy to try to write programs around. That's why there's tools like Airflow to allow you to orchestrate these different programs. So Airflow, what is Airflow? Basically, Airflow is just a way to programmatically construct these pipelines called DAGs, or directed graphs. You can use Python to define dependencies, programmatically construct workflows, and monitor your jobs in an easy-to-read web UI. Airflow is free and open source, so that's always good. And it comes with all sorts of things out of the box, like a really nice UI, connections to hundreds of sources, variables, logging and monitoring, and then pre-built executors, which are how work is to be done, and operators, which is what is the work to be done. I'll talk a little bit about what executors and operators are and how they work in Airflow. So Airflow has really 4 main executors, which are the sequential executor, the celery executor, the local executor, and then the Kubernetes executor, which is what we'll talk about this talk. But I'll also go over the other ones, just so everyone kind of sees the natural progression into the Kubernetes executor. And then for operators, so there's the official operators, right? These are the ones made by, one second, I gotta show here. So these are the ones made by Airflow, and of course, it's not going to load. Nice. Anyways, so those are the ones made by Airflow. So it's a short list, but it has stuff like S3 copy and things like that. That's probably So it's things like S3 copy and whatnot. And then there's contributor operators. These are ones made by first-party contributors, so companies that are actively contributing in the workflow, in the Airflow project. These companies include RVADE, Bloomberg, Capital One, for example. There's a couple of big companies that are in here, a lot of Fortune 500s. So they write their own contributor operators. So operators like maybe some Azure. So Microsoft may contribute copy to blob or something like that, copy to data lake, read from data lake. These are all operations that you would string together, similar to how I did those Python programs, to produce some output. So copy to blob, do some data munging, move somewhere else, that kind of thing. So what type of workflows are good candidates for Airflow? You know, anything you're doing like cron jobs or any type of data movement jobs, DevOps, MLOps, you know, things like that. So going over the executors, if you're not familiar with how Airflow works, sequential executor is what most people get out of the box when they download Airflow. This is what you would test locally with. So how this works is you have your single computer, right? This is either your main computer or maybe some VM in the cloud. So that is running the Airflow UI web server, which is in Flask. It's running the scheduler, which is a Python dynamic process. And it also leaves a single processing thread available open to do work. So similar to the first slide, say every day at 11 a.m. we wanted to operate that same first.py, second.py, that kind of workflow. What would happen? And then at 11:01 a.m. or 1 microsecond, we wanted to do uno, dos, tres, right? So what would happen at 11 a.m., it would operate sequentially. Even though these are pretty much running in parallel, it would still run this one first, wait till it finishes, and run the second one. The reason it does that is because there's only a single processing thread open, so you can't run parallel workflows. So if you have two things triggered at the exact same time, they would run one after the other, whatever one's supposed to run first. So this is not advised to use in production. This is something that you would use just on your thing, just on your personal computer if you're trying to try out Airflow. So the next one is local executor. This one you run on your personal machine. You can run in a VM in a cloud. This is a really popular one, right? So you have similar thing with the Airflow UI running alongside the scheduler, but you have your single processing thread and you can have multiple other ones. So this is really useful. There's a parameter in Airflow that says max parallelism, that depending if you have those cores available, you can run that many, so it depends how big your computer is, for example. But you have your first.py and second.py workflow, and I'm sure you can see what comes next, is that these two things can operate simultaneously and on separate processing threads. This is really useful if you have a really light workflow. Like say you have a single job that runs at 9 a.m. Most of the time people don't have that, they have a lot bigger workflows. But if you have just a single thing that you want to run every day at 9 a.m., you run this on just a VM, small VM, it's pretty cheap to run. And again, it's now getting on to the main show, the celery executor is what most people will run in production. So this is the de facto standard as of now for Airflow. And the way this runs is you have your single computer running the Airflow UI and the Airflow scheduler. The difference is here is that this computer is not actually doing any of the work. It is putting that work on a message queue. And this can be either RVADE in Python or Redis, which is another popular one. And then you have a slew of machines that can read off of this processing queue. So as many machines you want to have available, it can process all of those simultaneously. So this is a really popular workflow using a popular Python package called celery. And so, similar to the local executor, you have your first.py, second.py, third.py, and your uno dos tres, right? And they run separately, but the difference is here that these two workflows are running on separate machines. They're not running on the same machine anymore, they're running on two separate machines. And these machines are running all the time, available to pick up work. So, I want to talk about a fourth executor that I often see in these type of examples, and I've dubbed it the lazy executor. So what this is, and I'm sure we've all seen this, what often we call digital duct tape, or just kind of stitching things together. And so we have our Airflow UI, our Airflow scheduler. Then what ends up happening is you have some Python process that calls out to S3, Lambda, G-Cloud functions. I'm sure people have seen this type of orchestration done before. And the reason you may or may not do this is varied, but the purpose of this is you're pushing that execution onto some third-party platform. And it could be one of these, it could be Azure Batch, things like that. So it doesn't like to do work or can't do work itself, so it offloads that compute to another platform. I've done this before, but the question is, why do we do this? And so I think I've come up with 3 main reasons of why people do this. One is fast prototyping, security, and isolation. So currently, if you want to try out a new operator from scratch, let's say you have JavaScript operator, for example, if it's not given by Airflow or in the contributor section, you would have to write that you would have to write that operator from scratch. And Airflow's SDKs, it's very good, but you have to know Airflow, you have to spend the time developing this, and it may or may not work. So you have your JavaScript VM or JavaScript Azure function or whatever, and you're calling out to that just to make that fast prototyping easier, to make sure it works. The second one is security. So one of the downsides of Airflow is it can't store secrets. So connection streams it can store. But what about API keys, database passwords, login credentials, and that type of thing? And the last one is isolation, and this is the biggest one right here. So the way executors work is that they need to be able to run the workload, any type of workload that comes into that processing queue when it's presented. That means they have to have all the libraries and prerequisites for every single job because they need to be able to take every single job. So if a developer wants to use NumPy and another one wants to use SciPy, you either have to maintain both of those dependencies or you have to offload that machine to an external machine that has that dependency you're looking for. So what ends up happening is in the Celery executor, you have all of these VMs that have every single possible library made, every single TensorFlow version, every single NumPy version, and that kind of thing, just so you can support all of your workloads. And it's really bulky. You can do things with the Celery executor that allows you to get around that, but those are more VMs that actively have to be maintained. So it's very expensive, and it gets expensive quickly. But before we get to how to fix this, I want to introduce two technologies, Docker and Kubernetes. I'm going to briefly introduce these. Probably not doing them justice, but people that didn't or have not seen these or interacted with these, I didn't want them to feel left out. So Docker is broken up into really two types of things. And I know I'm grossly oversimplifying it, but I'm trying to explain it simply. So you have images, which are a snapshot of a file system. So these are everything on the computer other than the OS, basically. So the application, the dependencies, all of it are in an image. And then a container is an instantiation of this image. So you can think about it, even though it isn't, but you can think about it as a self-contained machine, like basically a VM that's run. And so to kind of give an example of how this works, so say you had the Node.js image, right? So the Node.js Foundation will put this image out there, and then people will create containers off of it. So we have like Node1.js, this may be a container. You may have like Node2.js, and so forth. So these are instantiations of this actual image. So that's kind of what Docker is in a nutshell. But Kubernetes is a little more difficult. So say we've taken our Airflow application and we want to Dockerize our Airflow application. First thing we would do is go ahead and Dockerize the scheduler. We would Dockerize the metadata database that it uses, and we would Dockerize the UI web server. But the problem is, how do these things communicate with each other? This is a common issue. So that is where Kubernetes comes in. So Kubernetes allows you to build containerized applications on a cluster. So Kubernetes runs as a cluster. So it's a cluster of machines that allow you to run Dockerized applications on them and allow for that communication between them, as well as a whole bunch of other cool stuff. So what does Kubernetes provide you if your container and if your application is Dockerized? It provides you networking, so it allows these two things, the multiple containers, to talk to each other. It provides you with self-healing. So say the UI web server was to go down. This would be bad in traditional infrastructure, but what happens is Kubernetes realizes this and will spin up a new one in its place. Scalability. So say the UI web server is getting like massive amount of traffic. We have like 100 users that wants to visualize the Airflow. It will actually spin up a new web server alongside of it, and so it allows it to scale infinitely, basically. As long as your cluster is big enough, it can just keep scaling, and it will scale back down. So when traffic is light, the web servers will be destroyed. You can see it allows for storage, right? So if I have a blob container full of, or some type of volume containing DAGs, like I said, directed graphs, for example, we can actually mount that, and that these things can actually read from that persistent volume. So it's very cool. We can mount that as just like a volume on the Kubernetes cluster, and these things can read from it, and write to it, and that kind of thing. So, and yeah, so much more that's like scratching the surface, but it's good enough for what we're about to discuss. So we talked about the different types of executors, and now we'll talk about the Kubernetes executors. This is probably why all of you are here, and the newest part of Airflow, the newest introduction to the family. So say we have the workflow on the left, like we're trying to demonstrate, where we have first.py, second.py, and third.py. So with Kubernetes, like I said, we have our Airflow UI and our Airflow scheduler, as well as a metadatabase. I don't think I put it up there, but these things are Dockerized in Kubernetes. So right now, there's nothing running but the web UI, the scheduler, and the database. So what happens is, in the first.py, it will create a new Docker image for you automatically. Off the bat, it will create a Docker image for you. This is the Python 3 image. So if you just use the Kubernetes executor and continue to use those operators from before, like the S3 copy and that kind of things, you will automatically get the Python 3 image by default. So it spins up a Python 3 image, runs your Python code, and then destroys that container. And then the second.py will spin up. It'll spin up a new one with your Python code, run that, and spin it down. Then the third.py will spin up, run your code, and spin down. So the benefits of doing something like this are clearly evident, is that you don't need, here. So scale, right? So Kubernetes gives you the ability to infinitely scale your orchestration engine. So I could have 1,000 things running, and they're just popping up and popping out of existence inside my Kubernetes cluster. As long as my cluster is big enough to maintain it, I can just keep scheduling tasks. And the cool thing is that when tasks are not available to schedule, it will scale to near zero. So the only thing that will be running is the scheduler and the UI, and nothing else will be running. No persistent VMs. Reduce complexity. So I know no one said they've used Airflow before here, but if you've used the celery executor inside of Airflow, it is a pain to set up, and it takes a lot of knowledge just to set something like that up. It's another component in your system. So now you need RVADE here, you need Redis, and you probably want Flower, which is how you visualize these tasks and things like that, web interface and all of that kind of stuff. So it is a pain to set something like this up. It is worth it because you can scale infinitely, but if you're approaching it for the first time, it comes with a lot of complexity. And then the last one is, no persistent workers. So like I just said, with Celery, you need those VMs sitting idle basically, ready to read stuff off of the queue. With this, you don't need any VMs sitting idle. Nothing sits idle. Things are provisioned as they're needed. So when work isn't available, they're not just sitting idle costing you money inside of the cloud environment, which is really nice. And then you have really fine-tuned control over your workers. So for each individual task inside of the orchestration pipeline, you can control the memory allocation, the CPU cores, your service accounts, that kind of thing. So every piece in your pipeline is tailored to whatever you're trying to build. So that's a Kubernetes executor. Very cool things. What you probably read in Meetup talk was the KubernetesPodOperator, which is my favorite thing. And this was introduced by Bloomberg about a year ago. So this is an operator similar to like a Python operator or bash operator or S3 copy operator or something like that. But what this does, so So we had our similar first.py, just like you saw before, right? What the Kubernetes operator asks is just one simple question. It says, what if we didn't have to use the Python base image, right? Like, what if we could use any image we wanted underneath our orchestration engine? Underneath our orchestration engine. So every task in your orchestration engine will get their own image. Well, if you can do that, then why can't we do first.pl, a Perl, right? And then second.js, JavaScript. And then third.java, right? These could be just running in your orchestration engine, but they don't have to be in the same language. They don't have to be in the same operating system. And what this is really useful for is if you have pipelines that may require, like, oftentimes you're probably not going to use different languages all around your pipeline, but you may use different libraries and dependencies on each step. And this allows you complete isolation between all of those steps. So, please work from here. This talk will not be very long. So here are the operators. So these are the operators that come out of the box for Airflow. You can see there's a decent amount in here. So you have the Python one, MySQL, JDBC, that kind of thing. So these are the main ones I was trying to show. It wasn't loading there for me. But here's the main show, Airflow, right? So like I said, Airflow is a complete UI, similar to any other like orchestration engine. It's not, just because it's open source, it's not like any worse or better than those. But you get every nice thing you get in an orchestration engine. I'm not here to really demo Airflow, but I want to pull out a couple of cool features. So you have your DAGs, like I said, your directed acyclic graphs. And then I have a couple of demos here. And in each of these demos, I can click into them. I can see so these are every time it operates. You see I prepped a lot for this. So these are the graphs. So first, second, third will run. I can visualize dependencies. All of my logs are gathered here. I could probably give a whole nother talk on just what Airflow is. But anyway, so here's the second demo. So you can see all these are using the KubernetesPodOperator, right? You can see operator right there. So I'll go ahead and kick this off. And wait a minute, at the same time, what I want to do is I want to show you the Kubernetes dashboard. So here we can see like our active pods. Pods are containers, basically, for all intents and purposes. A pod is a container, so don't let that verbiage confuse you. But we will go ahead and jump over to default and then go down to pods. And some of my testing for this is going to take away from the coolness that's about to happen, but I'll go ahead and trigger the DAG, right? And so now we can see that this DAG is running. This is the active run right here. And as we refresh, we can see that things are, so right now first is in progress. What's cool is if we open up the Kubernetes dashboard, see right here, 2 seconds, it just spun up a new pod in Perl. So this is running Perl code. It's just running print first, but it's running in Perl. So if we click into it, you can see the base image is Perl and it's just running print first, right? But we can go into the logs and that kind of thing. See it's printing first, that's all. You can see the logging is very good. And then this pod will spin down in a second. So, it's already done. So the pod spun down, took 29 seconds to run that. And then the second.js is running. So if I open this up, you'll see that it's running JavaScript, right? So it's using Node and printing out a second. And we can go and see, we can exec right into the, we can basically SSH into the container and run operations if we want to, but we can see that in a second. And then hopefully I did this right. There it is, so Java finished too. And so if we look at the code for that, so you see the first one's in Perl, the second one's in JavaScript, the third one's in Java.
Can you zoom
the third one's in Java.
Hey, Brandon,
takes,
can you zoom in a little bit?
sorry.
Yeah.
So you can see, sorry, here. It's not a ton of code, right? But I'm not doing really anything that impressive. But, so the first one's in Perl, second one's in JavaScript, third one's in Java. It's Java because it takes like 100 lines to print Hello World. So that is how it works, basically, in a nutshell. But I want to talk about
Hey Brandon, I have a question.
Yep.
How long does it take to spin up one of those new pods?
So you have that is one thing that it tells you when you go to use this. One consideration is that your pipeline will incur a little bit of additional latency to grab those pods down and spin them up. It is insignificant, I would say, for the benefits that it gives you, but it is not nothing. So just keep that in mind. That if you have a similar workflow and you want to Dockerize and do all that, you're going to incur a little bit of a penalty for doing that, but it's not super. It's not a lot at all. So.
Does it depend on the particular image?
So yes, I'll get to that. It depends on whether you're hosting your own image in your own container registry or not. So these images that we just saw are actually pulled off of Docker Hub, which is kind of like GitHub, but for Docker images. So those are the open source Perl one and JavaScript one and that kind of thing. If you're hosting your own container registry, especially if you're authenticating to it, that does create additional latency because you have to go through that authentication first. But again, it's minimal, and you wouldn't be doing that a ton. So I mean, you wouldn't have a ton of images you're pulling. Usually your pipeline wouldn't be a different image for all of those because it can actually cache the image once you pull it in the first time and use that image repeatedly. I'm actually telling it in my code not to cache it, so I can get the updated one every time. But yeah, you can tell it to cache it, so subsequent runs will use the cache. Good question, though. So the like I said, Kubernetes Operator, we did that one. Pretty cool. So the reason you would use the pod operator, right? So you have increased development flexibility. So Airflow's plugin API is great, but you have to know both Python and the Airflow API. And any new connector that needs to be developed has to be developed from the ground up. So it leads to development fragmentation between the code you want to run versus the code that runs the code. And I love this quote here. It's from Bloomberg Engineering. She says, Airflow in its design provides the wrong abstraction. Airflow operators, instead of simply orchestrating work to be executed, actually implement some of the functional work themselves. This means that Airflow operators inherently combine orchestration bugs with execution bugs. I'm sure some of you have seen this if you've used other orchestration engines, right? Like especially ones that have their own DDL. Is that those your orchestration bugs will mix up with your execution bugs. So what is, like I said, especially if they're their own SDK or DDL, a change on that end to that SDK may interrupt some of your operations, even though they're supposed to be totally separate. It often is not that case. So, and then non-prescriptive workers. Like I said, in the first case, Airflow can be used for a wide variety of use cases. One of them is orchestration, like we talked about. Like there's DevOps and that kind of thing. So isolation is key to managing everything that isn't the code. So custom Docker images, which is what we just talked about, will allow users to ensure that the tasks environment, configuration, and dependencies are completely idempotent. So you could create a new Docker image for every single step in your pipeline. That would be fine. You could also create a default Docker image, like if your company uses these libraries consistently, you could create a default Docker image, and then I would program my Python code against those. And you may have like 10 DAGs or whatever that are all using that same image, and then when you update it, all of them get that update. And then security, this is a really big one here. So the Kubernetes pod operator can actually, so Kubernetes, even though Airflow doesn't have its own secret store, Kubernetes does. So Kubernetes operators can utilize the Kubernetes Vault technology and store all of your sensitive secrets. So this will include the API keys, database passwords, logging credentials. But what this really gives you is that Airflow workers will never have access to this information. So the pods are only built with the secrets they need. So you don't have workers, and you may have this in type of celery executor, where you have the workers that maybe reach out to like HashiCorp's Vault, or may reach out to Key Vault or something like that. But the problem is those workers now have access to all of those secrets in your vault. And so what this gives you access to is to only, or it has direct connection to your vault. But these gives you the ability to pass those secrets in at runtime, and they only get the secrets that they need, each operator. So it's very cool. So, and again, if there's questions, just stop me here. I wanted to talk about this confused me when I was first going over this a while ago, is the difference between Kubernetes pod operator and Kubernetes executor. Because technically the Kubernetes pod operator doesn't need the Kubernetes executor to run it. I know it's confusing. It was to me the first time. All it needs is just a direct connection to Kubernetes. So say you have an existing Kubernetes cluster and you have existing Airflow. If it's on Celery, if it's on local, it doesn't matter. As long as you have those two things, you can start using the Kubernetes executor. And so, like I said, an operator just defines the work that needs to be done. So in this case, it's saying, Kubernetes, please spin up a pod to do this work. That's all it's saying. So again, this is running in local mode, or sorry, sequential executor, because we only have that one processing thread available. But what this one thread then says is Kubernetes, Kubernetes, please go spin up a first.py Docker image. And then give me back the logs, give me back all the information I need, progress, that kind of thing. And so that first.py that told Kubernetes to go spin up, will spin up in your cluster and then go away and come back, and log those here, even though we're not using the pod operator. I just wanted to make that kind of clear. I'll talk about it here, but there's kind of a hierarchy to running Airflow. So at the bottom is your local executor and your traditional operators, right? So these are the things you get out of the box, basically, with Airflow. Because Airflow is an open source project, just pull it down out of GitHub and run it, and this is where you kind of start with. I would then advise moving to the local executor and the Kubernetes pod operator. Like we just saw, there's a lot of benefits something like that gives you, and flexibility in your deployment pipeline. And then there's the Celery. This is where most, again, I know a lot of you aren't using Airflow, but like a lot of the Fortune 500 companies are here with the Celery executor and the original operators. They've built very successful data platforms here. So that are very mature, can scale, and all do all that fun stuff. And then there's kind of the, we get into like the creme de la creme here. You've got the Kubernetes executor and the traditional operators. What we saw here is that new Python-based images will be created to run your code. While you may not get that isolation that I was talking about, what you will get is the infinite scaling and resiliency that we talked about. So very cool technology there. And at the top, is the Kubernetes executor and the Kubernetes pod operator. It's kind of the whole point of the talk. So if you learn anything, is to go implement those. What you'll notice is that I didn't put Celery executor and Kubernetes pod operator. The reason I didn't do that is because if you're already, like I said, Celery is very difficult to stand up. So if you're already here, adding in that Kubernetes layer, what that means is that means you already have active VMs reading off of a message queue, and adding that Kubernetes component, it's usually easier just to jump up to the Kubernetes executor at that point, because it means you have a cluster, and you're going to get so much more benefits by just jumping up to the executor. It's going to require a similar amount of effort. So that's why I didn't put that there. I mean, it's not like you can't use it. This is actually what some companies use in their Airflow as a service solution, which I'll go over in a little bit. So it's not that it's bad, but I wouldn't consider setting it up myself because it would require a decent amount of engineering work. And so I want to talk about the gold standard architecture. And I did this one in Azure, but you can imagine that you could plug and play any of these components. So for our ACS container registry, we could like put EKS, we could put, we could put AWS's container registry in that place, and for our blob, put S3 and that kind of thing. But for Airflow, what I would suggest people to do if they're trying to stand up a similar architecture is to have their Airflow UI and their Airflow scheduler Dockerized, and this in itself is a challenge. Luckily, that Airflow project already has those available for you in GitHub. There you have the Docker images to run both of those things, so you don't have to do that yourself. Second one, big one, run Kubernetes as a service. For Azure, it's completely free. I'm not sure that AWS probably is as well. But it does give you a lot of cool things like automatic scaling and that kind of thing. And it's free, so use it. It'll make your life a lot easier. If you're familiar with cops and that kind of thing, you can use that as well. It's just that this is a lot easier for someone that's looking at this architecture trying to stand it up for the first time. The third one is to use a database as a service. So like I said, you could run your metadatabase in your Kubernetes cluster. That works perfectly well. Problem is, like, how do you do snapshots? How do you do that kind of thing? Scale, so when you have multiple sharding, all that fun stuff that us as data engineers don't like to do. You use MySQL as a service or Postgres. Airflow works with both of those. And Azure has a really cool offering where it will automatically handle scaling and all of that stuff. Of course, you could run, like I said, you could run the Airflow database as a container. I think Airflow gives you an example of how to do that. If I was standing up my own one, which I did in Azure, I would advise running metadatabase separately. That way, if Kubernetes goes down or whatever, someone deletes your pods and all that stuff, you still have your metadata. And then, so those DAGs, right? Those DAGs you saw in Airflow. Let me just show you. Again, if anyone has questions, please ask. So this is a DAG, right? This is a file, a Python file, but is a DAG. Like it is a graph. I can go here and see that it's operating here. So if I go back to Airflow, these are my DAGs that I have. I'm currently running Airflow. I can turn them on or off. They're set up on schedule. They can also run off events, right? So I'm not going to get too much into Airflow, but they can run off of triggers, like a file was dropped in Blob or S3. You can operate one of these directly off of that, and I can see my recent tasks and everything. But each one of these is a DAG, and it's a Python file. So you can think about those as your deployables. And then what you do is you host those deployables in a separate Blob account connected to your Kubernetes cluster. What this allows you to do is, so we're down here as data engineers, and we're developing these DAGs every day. That's what we do. And we push those DAGs up to here, it immediately will start to run. So we build our CI/CD pipelines down here, and this is like production or whatever. So you do your CI/CD, you test it, and then when that pipeline's ready, you go ahead and push it into this blob store, and it's immediately available in Airflow. Very cool. The last one is your container, your private registry. So again, you may, as a company, you may have like custom modules and things like that that you need to run. So you may have like these Python libraries that aren't public libraries. You can compile them here. You may have like containers that have secrets or connections to secret vaults and things like that. And you want to keep those private. Most of your companies probably already have some type of private container registry. So that's what you would use to grab those private containers from. Very cool stuff. You may be thinking, looking at this talk and thinking, like, how do I get started? Especially if you haven't used these technologies before, it can seem like very daunting, all of this. I understand. And again, I shared, I wanted to mention, I shared this slide on the RVADE GitHub. I'll post that link into the meeting for today. But this slide, as well as all of the Python, or all of the demos will be in that GitHub as well. So you're free to like pull it down and play with it. But so the first one's how to run Kubernetes on AWS. It actually is a really good one. I used that one and was able to get the whole Airflow infrastructure that you just saw running in like 2 hours. So it really wasn't that hard to do. The second one, honestly not as good, but it's you can use it. I had to munch with it a little bit, but was able to get it up and running in like 3 hours-ish. Kops just works really well with AWS. If you've ever used Kops, it's a command line tool for Kubernetes. And then, easiest of all is Google Cloud, G-Cloud. They have this tool called Google Cloud Composer, and this is a Airflow as a service solution. And it took me literally 5 minutes to get Airflow set up. Very nice, and I'll talk about that in a second. That's actually what I'm using for all of these demos. So I just said, Google Cloud, please go spin up everything you just saw, and with a click of a button, it spun it all up. It's not super expensive to run. I mean, it depends on how big your cluster is underneath, how big your Kubernetes cluster is, basically. But you can infinitely scale with it and all that fun stuff, with just a click of a button. And so I wanted to cover the people that that didn't know how to stand up cloud resources or couldn't. Some of the people that's in the private cloud and that kind of thing. So again, Google Cloud Composer, if you're not comfortable with writing ARM templates or writing AWS CLI command and that kind of thing, this again literally took a click of a button. So very, very nice, even just to get playing around with Airflow, and then when you're done with it, I think if you sign up for Google Cloud, 300 free credits, and that kept this up for like a month and a half now. So it allows you to play with Airflow if you just want to get started, and then just spin it down when you're done. The second one is Astronomer, and I played around with this I'm not like sponsored by this company or anything, but they're offering kind of Airflow as a service as well. Very cool company. And you can either deploy it in your own cloud or in their cloud. But again, click of a button. One thing I wanted to point out, I put a beware on this slide, is that Google Cloud Composer currently doesn't support the Kubernetes executor. It's coming. I keep saying it's coming. It is coming. Astronomer does support the Kubernetes executor, and they have a free trial as well. I think you can get two weeks for free if you want to try it out. And for the people that's still on-prem, Kubernetes loves servers, right? You can run Kubernetes, it's open source. You can run it on your server farm and deploy your applications directly in there. You don't need a public cloud if you don't want to. It's a little more involved, but definitely possible. And so, element links. These are a couple of links that I think are really good. I was putting this like I said, I'm going to share this slide out. But the first one's really good. It talks about how we're all using Airflow wrong and to use the Kubernetes executor. And then a couple ones by Kubernetes and by these last two ones are very good. This one's by Dailymotion. They talk about how they bring machine learning models into production quickly with the Kubernetes executor. And using Airflow and Kubernetes by another engineering firm. All of these are very good, so I would advise reading through it. And then I wanted to give one last example. And so what I did here to kind of demonstrate, it's silly, but it kind of shows the full power of what something like this is doing, is that I went out to the Meetup API. I wrote a little script, it grabs it, and this is in Python. And then from there, I was able to create run it in PowerShell to create a website with the API. I'm sure that's pretty cool. And again, all this code is on all these demos and stuff. So this is demo 3. Basically what it does is it monitors some Meetup data and then creates a website. And these are both KubernetesPodOperators. The first one's in Python, the second one's in PowerShell. We'll go ahead and trigger that. And hopefully we can see the pods if it didn't. Yeah, let that happen. Just another one. You can see the Meetup one is running now in Python. And again, we have all of the cool logging in Kubernetes, but all of these logs are sent back to Airflow. So I wanted to show that just in case you're not familiar with Kubernetes. So I can click here and view the logs of all of this activity. And like I said, it's all logged back to Airflow. So you can see what it did is it grabbed all the names of the people that RSVP. Thank you for RSVPing. And what it did is Airflow, like I said, this is an Airflow talk, but Airflow has this idea called XCOM. And what this allows you to do is pass variables between tasks. So even though these tasks are running in separate languages, I can pass data structures between them and not have to write those data structures out to intermediate disk. Usually what you have to do is like write this data to like a blob store or write it in S3 somewhere and pick it back up and that kind of thing. What XCOM allows you to do is pass basically JSON between tasks. So pretty cool, right? And again, we can see XCOM here, which are all the people that RSVP. And then the PowerShell create a website will run. And you'll see what this does is it goes out to Azure and basically creates a static website posted in Blob with those names that RSVP. So I'll show the, I have it pinned here. The VPN is probably going to block me, yes. Oh, yes. All right. So you can see nothing's spun up here yet, but come back to this in a second as it finishes. One thing I want to show, which is actually pretty neat, this job isn't finished yet. Let's look at the code. One thing I want you to notice, and so for the person asking, these are actually using.
You zoom in a little bit.
Everybody see? These are actually using my hosted Docker images. So what I did, and I'll show you how I programmed this. So I wrote the program, I created a Docker image, put it on my Docker registry, and created this RVADE DS create website image, and then RVADE Meetup image. So this is on my Docker Hub profile. And then for the person asking, the image pool policy is how you change like the caching and that kind of thing. So it always pull the most up-to-date image. And so I want to show the code real quickly because I think it's useful. To notice something here. Actually, you know what? I'll plug the RVADE it out here. And if I can show it, is classic. What I wanted to show is that, and you'll actually see it when we go back and look at the code, is that these are Python and PowerShell things running, right? But there's no Python or PowerShell, or actually there is Python, but there's no Python or PowerShell code executing here. All that code is pushed off into the Docker engine. It's completely isolated from my orchestration layer. So a bug here won't cause a bug there, and vice versa. But all those logs are put up to one discrete place. So very cool. And this is how you get XCOMs and stuff. But let's see if that finishes finally. So you can see it created a blob account called RVADE. In there, it holds a static website. Wow, this all works. And you can go to this address if you want to. Basically, it says, thanks for coming to my talk with everybody's name in RSVP. So you can see how you can start to build really cool pipelines off of this. And again, thanks for coming to my talk. I will start to field questions if there is any. But again, thank you.
It could just be, that this is a contrived example for the talk, right? But to me, particularly with this last one, you're using Airflow as a way to deploy containers, right? I just think that there are other tools that do that. Maybe like in production and at your job, you're not doing stuff that's this simple, but if you are, did you consider to look at other tools that do container deployments?
So what do you mean by that? Like, so this isn't deploying containers per se. I mean, it is in a sense, but it's running a whole orchestration underneath. So all the logs are logged at the same place.
Yep.
Like I have the ability to pass variables between two containers. I have the ability to run containers conditionally based on the output of previous ones. I don't know of any tools that currently do that. Maybe there is. I don't currently know of any.
Yeah.
I'd be interested if you have like recommendations.
Yeah, I guess so for my company, we were looking at using it. We were going to do it for like model training and stuff, in which case we would use like a Kubernetes like daemon set. Once everything's done, we take our artifact, all the pods spin down, I guess.